Good everyone, welcome to today's mathematics class. In today's class, we will be looking at some questions on integration, precisely definite integral. So we want to look at this question here. We are asked to evaluate the integral of x squared plus 2x all over the square root of 1 plus x. So this is the upper limit and the lower limit. So for us to solve this question, we have to use a substitution method. So substitution method is the only way we can be able to solve this question. So we start by saying let u equal to the square root, this one, the square root of 1 plus x, so that we will then have u square. So to remove this root, we will have to square both sides. So if I square both sides, so I will undo this root. So this will take square. It will now be 1 plus x. So let us make x subject to the formula. So from here, we can make here, this imply that what? X equal to, then just take this one to this side. Subtract 1 from both sides. We have u squared minus 1. So that is for x. So the next thing we are going to do is to differentiate in respect to x. So now, since u here is having a square, so therefore we are going to use implicit differentiation. Using implicit differentiation, so we're going to have differentiate this u here, going to give me 2u. Now, in implicit differentiation, you have to add the u, the x, because we are differentiating in respect to x. So that's why we are going to be adding the u, the x. Now let us come to this right side. If you differentiate constant, to give 0. Let's differentiate this to give us 1. So now let us make the x subject of formula. So this will now imply that what? If I cross multiply, my dx is equal to 2u du. Good. Now let us go back to our question. Let's substitute for, we're going to substitute for 3 things here. We're going to substitute for dx, we're going to substitute for x, and I think that's all. Then u is going to represent this. Okay. So here will now give us the integral 3 to 0. Then wherever you see x is now 1, that is u squared minus 1. That is the value for x. So use it to replace x. So here is having square. We're going to have a u squared minus 1. Then all squared. Then plus 2 into what? U squared minus 1. Then we have all over. The whole of this place is u. That's u. Okay. Then the x now is now represented by what? 2u du. So the whole thing, because this one is not a function of u, everything has to be u. That is 2u du. Good. So let us evaluate. So automatically this one will just take care of this u. So that from this side, we now have, let's continue from here. We will now have these two. Let's take these two outside. These two will go outside the integral. That is 3, 0. Then we have u squared minus 1. Then plus, okay, that is having us squared plus 2 into what? U squared minus 1 du. Okay. So let us open the brackets one after the other. Let's expand. Expand this one, then you open this. So that at the end of the day, we are going to be having 2. Okay, let's go further. 0, that's u squared minus 1 all squared. So let's just use this 2 now to open this bracket. Going to give you plus 2u squared minus 2. Then everything here is affected by what? Du. Okay. So very sorry, I'm going to manage this board. Let me manage the space. I'm actually looking for money to get a bigger board so that I can have enough space to work. So here, let us open this. If you open this one, let us expand. Your u square minus 1 is sitting as u square minus 1. So let us expand. Expand this times this to give us u raised to power 4, okay? Then u square times this to give us minus u square. Minus 1 times this is also give us minus u squared. Then this one times this is give us plus 1. So at the end of the day, I will have u squared to u raised to power 4 minus 2u squared plus 1. So it means the whole of this one is this. So I'm going to plug that into this place. So let us finish it from here. What to do now, let's bring this one. It will now be give us what? 2, the upper, the integral of what? Then we have u raised to power 4 minus 2u squared plus 1. Then plus this one here, plus 2u squared minus 2. Then everything we have du. Okay. Now let's simplify. This one and this one will go. This one and this will go. We have plus 1 minus 2. So that we now have what? 2, the integral 3 to 0 of u raised to power 4, then minus 1. I think that's what we are going to have. This one minus this is 4 minus 1, then du. Good. So let us integrate now. We can now integrate further. So integrating that, what we are going to have is you add 1, then you divide. Okay, that's the want to integrate x raised to power n. So integrating x to the power n going to give us what? X raised to the power n plus 1, then all over what? N plus 1. So that is what we are going to apply here. So that we now have 2 here, that is 3, 0. Now we have what? U raised to the power 5, because 4 plus 1 is 5. Then all over 5. The minus, this will now give us u. Okay, u. Now that is what we now have, the upper and the lower limits. So now let us begin to substitute for that. So now, remember this 2 is also here. What we do in a definite integral like this, the value of this upper limit minus the value of the lower limit. So we are going to put back what we have as our u. Remember that but u equal to what? But u equal to the square root of 1 plus x. So that means wherever u is now, we're going to replace it by what? Square root of 1 plus x. So we know that u is equal to what? Square root of 1 plus x. So now let us come and replace it with this. From here, we're going to have 2 now. We have 1 plus, that's root x, everything raised to power 5. Okay, raised to power 5, then over 5 minus 1 plus x, that is square root of 1 plus x. Then we have 3 and 0. So remember that this square root is setting as 1 plus x raised to power half. So that this will now give me 2 into 1 plus x raised to power, this will now be 5 over 2, then all over 5, then minus 1 plus x raised to power what? 1 over 2. Remember that is 3, that is 2. Good. So now let us evaluate now. So when x is 3, we plug it here, then subtract when x, oh sorry, this is 0. This is 0 here. Good. So let us minimize so that we now have 2. Then we are going to subtract now. That is 1 plus 3. When x is 3, that is the upper limit. Raised to power 5 over 2. Good. Then minus, here we have 1 plus 3 raised to power 2. Okay. So this one is for the upper limit. Now let us subtract the lower limit, which is when x is 0. Good. Remember, this 2 is multiplying everything, all right? So we now have a 1 plus 0 raised to power 5 over 2. Now, remember, there is going to be a bigger parenthesis, okay? Then minus 1 plus 0 raised to power half. Okay, sorry, because of the space, I don't have space here. So let's continue from here. From here, 1 plus 3 is what? 4. So which now give us what? The 2 now multiplying, which now give us 4 raised to power 5 over 2. Okay, then minus 1 plus 3 is what? 4. That is 4 raised to power 1 over 2. Okay, then minus what we have here. 1 plus 0 is 1. Then 1 raised to power 5 over 2 is still 1. Okay, then minus 1 plus 0 is 1 raised to power, that is minus 1. Okay. Oh, sorry, there is a mistake somewhere. So this is all over 5. Sorry for that. This is over 5. Then here is over 5, please. Okay. It's over 5. Over 5. Here over 5. Everything over 5. Okay. So now let us go. So what we have here is, okay, this will now give us 1 over 5. Okay, because 1 raised to power 5 over 2 is in 1. Then minus that. So we are going to be having like this. This one is stating as saying the square root of 4 raised to power 5. That is 32. That is 2 here. The square root of 4 is 2. 2 raised to power 5 is 32. This will give us 32 over 5. Then minus the square root of 4 raised to power half is stating as square root of 4, which is 2. Good. So we have this one here. Then 1 over 5 minus 1. Okay. Now let us review our work before I move further. Okay. I think here is going to be positive 1. Here is positive, yes. Look at here because of this negative sign here. Because of space, please be very, very careful. This is negative 1. It's multiplying whatever we have here because the upper integral minus the lower integral. The upper limit here minus the lower limit. So here it was already minus before. So this negative sign will affect there to become what? Positive. So now let us open this bracket here. So let's open what is here. Now we have 2. Then bracket. This will give us 32 over 5. Then minus 2 minus 1 over 5 plus 1. Okay. So now negative here and positive 1. So this will give us 2 brackets 32 over 5 minus 2. Okay, not minus 2 anymore. Minus 1, minus 2 plus 1, it will give us, let's take the fraction, that is 1 over 5 minus 1. So this is what we have here. So let us find the LCM. So the LCM is 5, of course. 32 over 5 minus 1 over 5 minus 1, because minus 2 here plus 1 is minus 1. So that we have 2 into the LCM there is 5. 5 goes here, that is 5, that is 32. Minus 5 goes here, is 5, 1, minus 1. Then here, 5 goes here, is 1 goes here is 5 times 1, that is minus 5. So what we are going to have now, it will now give us what? 32 minus 1 minus 5 is going to give us 26. That is 2 into what? Multiply 26 all over 5. So let us multiply by 2. 26 times 2, it will give us 52. 52 over 5. Then let us divide 52 by 5 to give us how many times? That is what? 10 over 2 over 5. So this is the final answer. So if you find this class very interesting, don't hesitate to share this video so that we can get to a greater number of people across this platform. Take your time, rewind the video, follow the steps, and you see yourself solving calculus like a piece of trash. Bye.